So you want to learn how to calculate the slope of secant lines corresponding to a certain given interval. In this equation, we're going to solve I first to show you how to solve these two. So the first thing we want to consider when we're finding an interval is that the interval 0, 40 is not an x, y necessarily, but rather it's corresponding to t, which is the amount of time in minutes we have. To find the even interval, we use this formula. Slope is equal to v1 minus v2 over t1 minus t2. Now, it doesn't have to be a v, but v would represent steps over here, steps, and then t would represent time. And so all we have to do is, instead of x and y, we just assume that 0 is 1 and 40 is 2, as well as their corresponding steps, because as we see, 0 minutes corresponds with 3,288 steps, and 40 minutes corresponds with 7,168 steps. So when doing these calculations, we do 3,288 minus 7,168 over 0 minus 40. So this would be t1, t2, v1, v2. And this is always assuming that you're given this table, right? So just rely on the table. There's no like imaginary numbers that you need to plug in this scenario. So once you have that, it should equal 97. That would be your answer for A, 97. And you would apply the same concept with these two. You look for T1, T2 for this one, steps 1, steps 2, and then same thing for 20, 30. You just okay. So now for part B, I went ahead and finished part 2 of A and part 3 of A for you guys because we're going to need them for part B. Not so much part 1, and I'll tell you why. So in part B, it wants you to estimate the student's walking pace in steps per minute at 3:20 p.m. by averaging slopes of 2 secant lines from part A. So if you look up here, it says that the table shows the number of steps recorded t minutes after 3 p.m. And this one's asking for 3:20 p.m. So what you're going to do is you're going to look for 20 minutes on the chart, right? Because 3:20, 3 p.m. to 3:20 is 20 minutes. So it's asking you to find it by averaging the slopes of 2 secant lines for this specific area from part A. So we're given these three, and what we want to do is we want to take the ones closest to this area in the chart and take the average. So in part 2 of A, we did 10-20. So we're going to take this side of it. And in part 3, we did 20-30. So we're going to take this side of it. The reason we don't take 0-40 is because it's really far away and it's calculating this whole area. We want to take as close to the middle or as to where we need to calculate as possible. So we just take the average. 106.3 plus 96.4 divided by 2, and that gives us 101.35, and then rounded it's 101. The reason why, again, we did this was because it was asking us to average the slope of 2 secant lines from part A specifically, so we don't need to create a whole new interval or whatever, and we ignored part 1 of A in our average calculation because it's very far away. It's not really representative. It's calculating from here to here, which the average is 97, but we want a more specific average, and as you go through Calculus 1, you'll learn